we just did a simulation to see whether the general population prefers to tilt their head right when they kiss, or there's no difference. However, we normally don't use a simulation to do that. Instead, we do a hypothesis test. So here's an example. In our kissing example, we start by assuming the null hypothesis is true, or the probability of tilting your head to the right is 50%, because you have the same probability to go to the left. So first we check our conditions. Was it a random sample? Yes. Okay, our independence condition. We are assuming 124 people is less than 10% of the population, assuming the population is greater than 1,240. And then we check our normality condition. The n p hat is greater than 10, and n q hat is greater than 10. And again, that works. So we know what our distribution looks like. It's fairly normal. So we are going to actually try to figure out the shape of the distribution. And we're going to do that by saying it's centered around p hat with a standard deviation of p hat, q hat all over n, or it's centered around 0.5 with a standard deviation of about 0.005. So it should look like this curve. And what we want is the probability of getting 6.669% of the population to tilt right, assuming that it was really a 50-50% chance. And when we did it from a simulation, we got 0. If we put it in our calculator, we'd also get about 0%. And here would be the calculator stuff. All right, note, the value of z is called a test statistic, and it tells us how many standard deviations the observed value is from the hypothesized value. When doing a hypothesis test, it is customary to report the value of the test statistic with the p-value. So if you remember, to find z, we do our observed value minus the average, or the actual value, all over the standard deviation. So using our formulas, our actual value of 0.669, or it was about 2/3% of the population tilted to the right from the sample, has a z-score of 3.76, which is why the probability of occurring was 0%. It was way over 3 standard deviations from the mean, or from the average that we assumed to be true of 0.5. So the probability of getting a p hat greater than 0.669 is equal to the probability of getting a z-score greater than or equal to 3.46, which was 0%. So looking at that, we could say, you know what, it's so rare that it could happen if it really was a true value of 0.5, that it probably isn't a true value of 0.5, since we have evidence from the real world that 2/3 of the population tilts to the right. Here are the 5 formal steps that we could use to write that out. At first glance, it appears that the true proportion of couples that tilt to the right, p, is greater than 0.5, since from our sample, we got a p hat of 0.669. However, it is also possible that the true proportion is 0.5, and we got a sample proportion this high due to sampling variability. It just happens that when we were creeping in the bushes, peeping on people making out, that we just had a lot of people in that park or wherever we were looking that tilted to the right. But really, it's 50-50. To decide, we will conduct a 1-sample z-test for p with a significance level of 0.05, which means that if the probability we find of having 2/3% chance of, 2/3 of the people tilting their head to the right, assuming it's really 50-50, is less than 5%, we're going to reject our null hypothesis. And our null hypothesis is that really it's a 50% chance to tilt to the right. And our alternate hypothesis is that it's greater than 50%, because based on the real world, it seemed that it's more like 2/3. Again, check our conditions. Okay, random sample of couples. Well, it wasn't as stated, so we will assume and proceed with caution. Okay, independence condition, yes. Assume that there are more than 1,240 couples. And is it a large enough sample size? Yes. Again, because NP is greater than 10 and NQ is greater than 10. And I actually think I have the wrong values here. It was the values I had up here, 83 and 41. All right, we want to find the probability of p hat being greater than 0.669, which would be the same as the probability of the z-score, which we had as 3.76. And when we put that in the calculator, we got 0. Again, at this spot, you would want to draw the curve in with your average. We're at 1, 2, 3, over 3 standard deviations to get this. So you can see that it's a very small probability. And then in this case, since it was a 0% chance, since the p-value is less than alpha, or 0 was less than 0.05, which you should write in, we reject the null hypothesis. Again, our null hypothesis is that it's a 50% chance of tilting to the right and 50% chance of tilting to the left, and conclude that the majority of couples kiss the quote-unquote right way. In general, there are only two ways to make conclusions. If the p-value is less than alpha, we reject the null hypothesis and conclude whatever we have in context. We conclude the alternate hypothesis. Or if the p-value is greater than alpha, we don't have enough evidence to say that what we saw in the real world couldn't have just been by random chance. And so we have to fail to reject the null hypothesis. And there's the z-score formula again that I used all the way up here and on the previous page. Note, the book uses a slightly different procedure, which is very similar to my 5-step procedure. Please use mine. Note, since checking conditions and calculating p standard deviation of p hat, we always use the true value of p if we know it. We don't know it often, but we are going to use it. Since we assume a value for p in the null hypothesis when doing a hypothesis, we will always use this value. With confidence intervals, we do not make any assumptions about the true value of p, so we have to use the estimate value of p. Now that I think about that, it's been a long time, that is where I got the different values here. Because I use the true value of p for n times p, 124 times 0.5, and nq, 124 times 0.5. So again, to clarify, for confidence intervals, you'll go ahead and use p hat, q hat, but for hypothesis tests, we'll use p and q. Hopefully that'll make it stick in your mind. Finally, if any of the conditions in step 3 are not met, state your concerns and proceed with caution. Okay? The biggest issue is this last condition right here, but you should proceed with caution no matter what. State your concerns and proceed with caution. We will do the last one in class together. Thank you.